Well done if you've got this far. We're going to go through the solution to the vectors problem now. So first of all, we're going to have a look at question 1, and we're given some information here. We're told that it's a parallelogram shape, and that's important because it's telling us that these sides here effectively have the same vectors, and so do these two sides. It's telling us that M is the midpoint of CB, so it's halfway along here, and N is the midpoint of AB, so that's halfway along, and they're important bits of information. Now, the first part of the question, it says find in terms of A and or C the vectors MB and MN. So I'm going to do it up here so you can see on the diagram. So MB and MN. So how are we going to do that? Well, let's start with MB first of all. So we know that this is the vector A, and so you can see that that's the same as over here, and M to B is just a half of A, so that's exactly what we write. MB is equal to a half of vector A. Now for vector MN, so to go from MN we go up to B, and then we go back along this way. So we already know the first part of it. We know that to go from M to N you go halfway in the A direction. And now we've just got to work out what this is. Well, if you look down the bottom you can see that C is this vector here. And if I take that up to the top you can see that B to N is half of C. So we've got half of C, but we are travelling along it in this direction, and this is the opposite direction to C, so it's a negative. So negative just means you're going in the opposite direction. So that's our first two sets of answers. And then we're asked, for part B, we're asked to show that CA is parallel to MN. So going back to the diagram, so CA is parallel to MN. Well, we've worked out MN. MN is over here. So the logical thing to do, whether or not you really understand what you're doing, is to work out what CA is. So C to A. So the easiest way to go from C to A is simply to go along here and then up there. So very straightforward. CA is equal to minus C, because it's in the opposite direction to C, and then plus A, because it's in the positive A direction. So we went from there to there. Now, you can see that MN is equal to, and I'm going to take the half out of here, it's a half brackets A minus C, and you can see that CA is actually the same as A minus C. I've just rearranged the signs. Notice it's still a minus C and a plus A. I've just turned them round. So you can see that this shows us that they are in the same direction. Vectors are in the same direction MN is just half the length of CA. And same direction means parallel. So we've shown them that. Right. Question number 2. Now, first of all, we've got express the vector xy in terms of A and B. So x to y, we can't go directly here, we don't know what it is. So to go from x to y, there's only one way we can go, is back along here and then up here. So let's do the first bit. This is the opposite direction to this vector, so the first thing we're going to write down is xy is equal to minus 2a plus b. And it's minus because it's in the opposite direction. And then we're going to go along here in the positive direction, so it's plus 4a plus 3b. So that's the first bit there. So we're now going to give it our answer in simplest form, and all that means is just multiplying all this out and tidying it up. Pardon me. So this is minus 1 times the brackets. We've got minus 2a minus b plus 4a plus 3b. And then we just tidy that up. So minus 2a and plus 4a makes 2a, and minus b and 3b makes positive 2b. So that is our vector xy. Now, looking a bit more tricky now. Let's just notice the similarities though. Notice this bit at the bottom here. This is the same that same sort of bit of diagram we've just worked out in the first part. So we're going to be able to use our bit of knowledge already. In fact, we could probably write it on here that xy is equal to, and we'll just have a quick glance up, 2a plus 2b. So we are after the vector o to z, and we can't go along that line because we don't know what that line is, so we have to go along lines we know. So we can go along here. So the first part of it, o to z, is clearly going to be along this vector here, and we know what it is. It's 4a plus 3b, so it's 4a plus 3b. Now the question is, what's this bit here? And for that we're going to need to understand this piece of information here. So the line, there are 5 parts here, and what this is telling us is the xy part is 2 parts and the yz part is 3 parts. So this is 2 parts long and this is 3 parts long. Now if we look at the xy part, it's 2a plus 2b. So one part will just be 1a plus 1b, and therefore 3 parts is 3a plus 3b. And you can see that kind of makes sense here because y to z is going to be 3a plus 3b. These are our 2's and our 3's. So hopefully you can see if that makes sense. So all I've got to do is add that on to here, because I'm going along here from o to z, I'm going from o to y and then y to z, positive direction. So it's plus 3a plus 3b. And again, simplest form, 4a and 3a makes 7a, 3b and 3b make 6b. And there we are. Now for the challenge question. And believe me, this is a fair old challenge. So, off we go. So let's just have a quick look at the diagram first of all and put down what we know on it. So O to A is 4A. So this bit here is 4A. Let's draw the arrow on it. And it's that direction. O to B is 4B. So that's 4B. Feeling better yet? Well, we'll see. Lots of straight lines. AC is equal to 2OA. So that means it's double OA. And we know what OA is, it's 4A. So AC must be 8A. So that's this bit here, A to C, and that's 8A. And finally, QB to QC is 1 to 3. So that's 4 parts. And the first bit, B to Q, is 1 bit long, and the second bit is 3 bits long. So that's all of this writing here now on the diagram, so we can kind of ignore that now. So part A, we're going to find the vectors which represent BC and AQ. So I'm going to do all that up here, so BC and AQ. So let's start with BC. They usually give you the easy ones first. So B to C. So, well, we can't go up there directly, can we, because we don't know what the vectors are. So if we go from B to C, we'd have to go back along here and then all the way up there. So that's the route we can take. So it's going to be minus 4b, because it's in the opposite direction, and then it's going to be plus all of these a's. Well, there's 12 a's there, so it's plus 12a. So that wasn't too bad, was it? Now a to q. So that's this bit just here, isn't it? Well, we don't know what that gap is, so we're going to have to do it a different way. And I'm thinking to myself, well, I've just worked out what BC is, and this is 3/4 of it. So I'm going to go up here to go from A to Q. So I'm going to go 8A positive, and then I'm going to come down here, and this is 3/4 of the one I just worked out, but it's the reverse sign of it, isn't it? Because B to C is minus 4b, so it's going to be opposite sign, so 4b minus 12a. So that's C to B. So I've gone up there and then down there. And I'm going to simplify this up a bit, so I've got 8a plus, now 3/4 of 4 is 3, so it's going to be 3b, and then 3/4 of 12, well, that's 9, so minus 9a, so that works out to be 8a minus 9a, it's minus a plus 3b. And that's our first bit there, minus a plus 3b. So I'm just going to highlight those answers so that it's very clear what they are. So AQ is that, and BC is that. Now, what do we need to do next? Given that BX is 8b, show that AQX is a straight line. So BX is equal to 8b. So BX is 8b, and we need to show that AQX is a straight line. So we're going to write that down here. Show AQX straight. So if it's straight, what that means is AQ and QX are parallel. So this implies AQ and QX are parallel. And we know what AQ is, it's up here, AQ is that. So we just need to work out what QX is. So how do we go from QX, Q to X? Well, here's Q, here's X, we're going to go down here and along there. So this is minus 1/4 of CB. So it's minus 1/4 of, and CB is, this is, remember it's the other way around, it's 4b plus 12a, because I'm going in this direction. This is the CB direction, and the BC vector here is obviously the opposite direction, which is why I've changed the signs on both of these. So that gets me down to B, and now I've just got to go up the 8b, so I add 8b. And we just work out what this is. So minus 1/4 of 4 is minus 1b, and minus 1/4 of 12, well, 1/4 of 12 is 3, so it's going to be minus 3a. And then we've got our plus 8b, and that simplifies down to 7b minus 3a. Now I've just noticed that this doesn't look very much like this, and I'm expecting it to look a bit like it because they're parallel, so I must have made a mistake somewhere. So I'm just going to go and have a look for it. Now I'm going to have a look at this because it seems to me I did too many things in this step. I've got this minus 1/4, and then I've switched the signs, but I've also, I can see I didn't switch to 12. So what I'm going to do is I'm just going to rewind to here, and I'm just going to run myself through this step again, just so I'm really sure that I've done the right thing. And it's always a very sensible thing when you're working on problems. Don't expect to get it all right first time, but what you want to develop is the ability to spot where you've gone wrong and be suspicious about what you've done yourself. So Q to B. So it's a quarter, or minus a quarter, of BC. So it's a quarter of BC, but it's in the minus direction. So I've put the minus there, so I don't need to switch the signs, I think is what I'm saying here. So minus 4b plus 12a. And I haven't switched the signs because I've put this minus in here. So I think that seems to me to be where I went wrong. So let's run that through and see what we get there. So minus times minus is going to be a plus, and a quarter of 4 is 1, so it's 1b, or just b. And then a quarter of 12 is 3, but it's minus a quarter, so it's minus 3a. And then I've got my plus 8b. And this gives me, when I simplify it, minus 3a plus 9b. And that looks a bit more useful, because if you look here, I've got a minus a and a positive b, so that's the right way around. And then you can see that there's a common factor of 3 in here, so let's just take that out. So it's 3 times minus a plus 3b. And that, of course, matches AQ. There's AQ. So we could say that QX is equal to 3 times AQ. Therefore, QX and AQ are parallel, and AQX is straight. I hope you followed that. If you didn't, then feel free to send me an email and I'll go through it. I'll have another go at doing it. But you can see these things are quite complicated, or they can get that way.